Welcome back, students. In this session, we are going to look into using row operations in order to find the inverse of a matrix. In this chapter, our curriculum requires the application of row operation in order to discover the inverse of a matrix. How are we going to do it? The very first result we know is whenever you multiply a matrix with identity, you get the same matrix. Or I can put it other way around, A is I times of A. Then by definition, we also know A inverse same as A inverse times A and each equal to I. So let me put it other way around. I therefore is, can we not say it is A inverse A? So compare these two statements, statement 1, statement 2. What is the statement 1? A is same as I times A. Second statement says I matrix is A inverse times A. What is interesting, striking feature of this these two statements? The position of the matrix A on RHS is same. It is not altered. So what happens? By continuous application of row operation, we want to ensure the equation in format 1 is transformed completely to equation in format 2. That is, I matrix is equal to A inverse times A. What that effectively conveys to you is the LHS, the A matrix present in LHS is transformed into I matrix. And when you do simultaneously the operation on the RHS ensures that I matrix is transformed into A inverse matrix. So that is the advantage of using row operation. So row operation you can apply on any row, make sure the same operation is applicable on RHS also. Point number 1. And point number 2, we follow a very, what you call a systematic or there is a hierarchy order in which you have to convert matrix A into I matrix. You know I matrix has one in diagonal, only once in diagonal, and all other elements are zeros, which means we need to convert zeros first of all, other elements in other places other than diagonal elements must be converted to zeros, and later we will convert diagonal element to ones. Let us see how that happens. By means of an example, let us do it. I'll put it as a question. Find the inverse of. Let us begin with a simple 2 by 2 matrix, and as a next level we can proceed to 3 by 3 matrix. I'll put some simple numbers here. Okay, what I have put is 2, 1 in first row, 3 and minus 1 in second row. Okay, so let us call this matrix A using row operation. Sometimes it's also called elementary transformation, using elementary transformations. Elementary transformations has ambiguous meaning. You can either follow row operations or column operations. Okay. And once they mention follow elementary operations, students are free to choose either row operations or column operations. So in this session we are just going to use row operation and arrive at the inverse. So let us first write the statement in the form of first statement. A is, and what is A? In place of A I am writing 2, 1 and 3 minus 1. I on the RHS, I am not writing the other same matrix once again. We are leaving it as a symbol A. And I matrix 1 0 0 1, 1 0 0 1 having the same order 2 by 2 as that of given matrix A has to be written on RHS. Now we start applying row operation. When I say row operation, I told you the hierarchy or the order in which we have to convert elements to zeros. Let us understand what are the diagonal elements here and what are the elements other than the diagonal. Position in row 2 column 1, position 8 to 1, that is number 3. This has to be converted to 0. And position 1 2, first row second column, has also to be converted into 0. But what is the priority? First we concentrate on column 1. In column 1 you complete your job of converting elements which are not in diagonal to zeros, and later on we proceed to the next column and do the same operations. Okay. So in column 1, the only element which you need to convert to 0 is the non-diagonal element in column 1, which is position 2 1. So this is converted. This is converted to 0. That is the idea. How is this possible? Well, I will give you some kind of hint which you can easily follow. In class 10 you used to solve simultaneous linear equations in x and y by using the elimination process. Eliminating the one variable, one by one you used to eliminate by making their coefficients equal and subtracting. Making their coefficients equal and subtracting. I hope all students they have the prior experience. Same way, consider, you can assume, so this is a element having, you can assume there is a 2x here, this is a 3x here. So how will I eliminate this element x here? I have to take the LCM. I have to take the LCM between 2 and 3, and I have to make suitable multiplier to reach the LCM, to get the LCM. So this is considered it as a rough column. The LCM between the two numbers 2 and 3, okay, confined to column 1. Our focus is on column 1. Our focus is on eliminating this 3. So how is it done? We consider the LCM and choose suitable multiplier number. Okay. So what is the number with which 2 should be multiplied to get 6? Students can make a plan in mind. What number you will choose to get 6 by multiplying 3 with what number? Okay, so very simple. And in essence, our intention is to convert this to 0. So when I say this element, where is the element present? Row 2. Okay. I am now going to write a symbolic language. Now we are going to plan for the operation. The operation is written in the form of a symbolic language. When I say 3 is to be converted to 0, we cannot perform the operation on that element alone. We have to perform the element. Understand, the row operation means, the meaning of row operation itself means you cannot apply the operation to just one singular element there. That element is present in row 2, therefore the operation applies to the row 2. If that applies to row 2 in LHS, it applies to row 2 of RHS also. So understand, when I am multiplying 3 with what number to get 6, I have to multiply with 2. And where is the 3 present? In row 2. Okay. And how will you eliminate it? By subtracting the 6, which is from row 1. So what happens is 2 is converted into also 6 by multiplying it by 3. And where is the 2 present? In row 1. Okay. After making 2 times row 2, I get 2 into 3. Okay. That's what is most important. Other numbers, right? I understand all numbers are multiplied, but still what matters for us is the first elements only. So 2 times R2 implies, what it implies, let us see. I am writing in rough column what it means. And 3 times R1, what it means. 2 times R2 means entire, there are 2 elements on LHS, 2 elements on RHS, multiply them by 2 and write the result. I get 6 minus 2, 0 and 2. Am I right? Multiply 3 times that element 2, but I cannot do that singularly. I need to do it for the entire row 1. So 3 times row 1 gives, all elements multiplied by 3 gives 6, then 3 and 0. So this is the implied meaning. And you are going to subtract, and only if you subtract, I will be able to eliminate this position, that is A21 position. I am able to convert it to 0. You are subtracting. Because you are subtracting, sign changes everywhere. So the second element becomes negative 5, third element becomes negative 3, 2 minus 0 gives 2. And where are we going to store this result? These 4 numbers in row 2 only. Therefore, this is the symbol. Row 2 gets transformed to twice row 2 minus thrice R1. Please understand it looks like some kind of, maybe for you, chemical reaction. So row 2 is transformed into 2 times of row 2 minus 3 times of row 1. Okay, value altogether in the equation does not change because you have applied it to both LHS and RHS. Apply it. Also, students, make note, we have not made any change whatsoever in row 1. So row 1, you need to copy it as it is. Why didn't we make any change to row 1? If you make any change in row 1, the diagonal element will get disturbed. Our intention is not to disturb any element in diagonal. We want other elements to be converted to zeros. Okay. So our first success, yes, we have converted this 3 to a 0, and other elements are 0, second element minus 5, RHS second row, first element minus 3 and second element 2, done. So this I can say, this is the first step of success. We want 2 elements to be converted to zeros. Compare it with I matrix and given matrix. You understand one more element has to be converted to 0. In the last step, what we did, there is a non-diagonal element which is 1 present. Now this 1 has to be converted to a 0. How it is done? How did we do here? By comparing with the diagonal element. But the diagonal element here, that was 2. Okay, by taking LCM with 2, it was possible for us to get a 0 here. Same way, I will be in a position to get a 0 here by comparing this number 1 with diagonal element in this column, which is minus 5. So by considering the LCM between 1 and minus 5 and making suitable operation, I will be arriving at 0 in this position, that is row 1 column 2. So that is the order we follow. We strictly stick on to this order right from the beginning of 2 by 2, so that you carry the same discipline when you operate on a 3 by 3 matrix also. Let's do it. This is order step 1. In rough column, I can just mention what we are going to do, the order in next. We are going to follow in column 2 the position 1, 2 is converted into 0. By considering LCM between the numbers 1 and minus 5. So ignore the sign for the present. Okay, the LCM between number 1 and 5, magnitude, LCM is 5. Okay, LCM 5, very easy to achieve. How the number 1 can by suitable multiplier I can make it 5. So 1 has to be multiplied by 5, 5 has to be multiplied by 1. Of course, students know there is a minus 5 multiplied by 1. Okay. So row 1, when I say 1, I cannot singular out, I cannot separate the 1 and multiply. That 1 is present in row 1. So I have to multiply row 1 with 5. So it is 5 or 1. Second row, it's already 5. So I need to multiply by 1. So it is 1 into R2, which I did not mention as 1 into R2, it is R2. Then imagine after multiplying what you are going to get. 1 when multiplied by 5, you will be having a 5. Minus 5 after multiplying with 1, you will be left with minus 5. So if you add both numbers, you will get 0. If you subtract, you will get 10. So here, make sure the operation is not always subtraction. The operation could be addition also. Okay, our aim, the aim of the whole row operation is to arrive at a 0. Okay. So by checking out the numbers after multiplying, I understand we are getting a 5 and a minus 5. So I understand addition gives 0. And where are we going to store the result? In row 1. In row 1. So row 1 is transformed to 5R1 plus R2. This is how you write the row operation symbolic equation. And just like we did here, write down in rough column, maintain a rough column. So students understand this kind of problem requires maintaining a proper rough column. 5 times R1. R1, please note, the elements are 2, 1, 1, 0. We are going to multiply simultaneously by 5. So you get 10, 5, 5, 0. Row 2, you are simply copying the numbers 0, minus 5, minus 3 and 2. And the operation is addition. So the result of the operation 5R1 plus R2, what is it? 10, 0, 2, 2. Is that clear? And where you are going to write this result, we are going to present it in row 1. At the same time, make sure we have not made any change in row 2. So row 2 can simply be copied from the previous step. You can simply copy. Done. The result of row operation available, you have evaluated in the rough column. Your job is just to copy now. Okay. The trouble of multiplication, addition, you have already done. Copy the result here. You got the result as 10, 0 in row 1, 0 minus 5 in row 2. I am discussing LHS. Now what is yet to be done now? We know our LHS should be in the form of the second statement. What is the second statement? I matrix is equal to A inverse A. Well, A is there, you can see it. I am yet to get I here. But it is very simple because row 1 has a 10. It has to be made 1. So the operation is very simple. R1 has to be R1 divided by 10. And what about row 2? Okay, in mind you can check out 10 by 10 gives 1, 0 by 10 is 0, 0 by what number next? Okay, in row 2 I have to get a 1 here, but there is a number minus 5 present. So I have to divide every element of row 2 by minus 5. Once I am able to complete this step, I will have A inverse on the RHS. So I am just writing blank matrices. Okay. Execute R1 is divided by 10. Go on, 10 by 10, 0 by 10, 2 by 10, again 2 by 10. Is that done? What about division by minus 5 in second row? 0 divided by minus 5, minus 5 divided by minus 5, minus 3 divided by minus 5. So minus sign cancels, and 2 divided by minus 5 gives 2 by negative 2 by 5. Is that over? Done. Well, the row 1 in RHS requires some simplification. It's possible. 1 by 5, 1 by 5, 3 by 5, negative of 2 by 5 multiplied by A. Now, this is in the form of I equal A inverse A. So, the matrix which is in the position of A inverse actually is the inverse matrix required. So, we arrived at the answer. Well, so shall I commit now? My answer for A inverse is what we got, 1 by 5 and 1 by 5 in row 1, 3 by 5 and negative 2 by 5 in row 2. Okay. Now, students and me also, I am very doubtful of my own result. I am not very sure. I got some numbers, random numbers. There is a 2 by 2 matrix, of course. But how am I to believe that this is your inverse matrix of the given matrix 2, 1, 3, minus 1? So we have to ensure. So before students submit it as a proper solution answer, okay, make sure your solution is 100% correct by verifying. How do you verify? Verify, it's here. A into A inverse, I must get I matrix. Whether I do A into A inverse or A inverse times A, I am supposed to get I. A inverse is already present. So why not I take the matrix A, okay, or I can do it that also to be done in the rough column. I will place the matrix here 2, 1, 3, minus 1 A. A inverse is here, okay, and in rough you can directly proceed to write the product A inverse A. Am I right? A inverse A 2 by 2 matrix. How do you write the answer for multiplication, the product? Okay, you know, you remember first row, first column. Let us do it. 1 by 5 into 2, 2 by 5. 1 by 5 into 3, 3 by 5. So cumulatively you have to add, and because it is a fraction, I am just writing it. The result you can write later. First row, second column, it is 1 by 5 into 1, 1 by 5 into minus 1. So 1 by 5 minus 1 by 5. Done. Second row, first column, 3 times 2, 6 by 5, minus 2 times 3, minus 6 by 5. Done. And second row, second column at last. So you get 3 by 5 into 1, minus 2 by 5 times minus 1. So you get plus 2 by 5, and the answer, are you observing, it is 1001? That's wonderful. That's wonderful. So that's what we were interested in, the product A inverse times A or A inverse, whichever way you do the product, because it is commutative, you are supposed to get I. Anyway, this is not required to be presented as part of the solution in when you do the answering for CBSE or any of your class exams. A inverse, this is obtained. So you are 100% now sure that you are going to secure complete full marks allotted for this question. Thank you. We will end here, and the next video I will show you how to do the same procedure for a 3 by 3 matrix. Thank you, students.